let's see this question in plastic analysis. So we have this section. So the question goes this way: find the shape factor of the T section shown in the figure above. Also find the fully plastic moment if Fy is equal to 24 kilonewtons per millimeter square. So and it's 15 marks. So we have two parts in this figure. We have the flange and the web. So first we'll have to write this. So solution will be for the shape factor. So we'll have to write this formula: ay prime is equals to a1 y1 plus a2 y2. So we'll have to make the substitution, but first we'll have to say we'll have to divide this figure into two parts. That's the flange and the web, the flange and the web. So we'll start with the upper part. So the area of the upper part is BH, of which it will be 100. You multiply by its height is 10, so it will be 1000 millimeters square. And then the lower part, the area will be PH, of which it will be 90. P is 10 times 90, so square equal to 900 millimeters square. So the total area will be the upper part, and then you add the lower part. So it will be 100. That's the A 1000 plus 900. So total area is 900 millimeter square. So we are remaining with the neutral axis. Neutral axis one goes through this point, the middle part of this 10 millimeters. So it's at this point. So our neutral axis will be then divided by 2. So it will be 5, 5. So our neutral y1 is equals to 5, and y2 will be, y2 is the middle of this web part. That's 45, 45. So it starts from this point 45 to the beginning of the flange is, you'll add 45, then you add 10. 45 plus 10 will be 55. That's our y2. So it's 55. y2 is 55 millimeter. So let's substitute. So we'll start with this area. The total area is 1900. So A total is 1900. You multiply by y prime, we don't know, is the same as A1 you multiply by y1. So A1 here is 1000. So 1000 you multiply by the y1, which is 5, bracket 1000. Then you add A2 900, you multiply by y2, which is 55. So it will be 1900 y prime plus y prime is the same as, you multiply this 1000 times 5 plus 900 times 55. So this one would be 54 500. So to remain with y prime, you divide both sides by 1900. So y prime is the same as, answer you divide by 1900 will be 28.68 millimeters. So that's a neutral axis. So but we'll have to find also the y max. Y max, you'll say the total height, which is 100, you multiply by you subtract the neutral axis. So therefore our y max will be 100. You subtract 28.68. So it will be 100 minus 28.68. So 71.32 millimeters. That's our y max. So we'll have to do also the second moment area. So I is the same as BD cube for the rectangular part plus A1 into the neutral axis minus neutral axis 1 square plus BD cube for the rectangular plus A2 in neutral axis minus neutral axis 2 square So we'll have to make substitution. So our P, so flange, we have flange and the web. So flange we have B is the same as 100, then H is equals to 10. For the web part, we have B is 10, then H is 90. So we'll make substitution. So we'll substitute this formula, so it will be B is 100 times 10 cubed divided by 12 plus A1. A1 was 1000. You say that the neutral axis now is this one. The neutral axis we got is 28.68. We say 28.68 millimeters. You subtract the first neutral axis at this point. 10 divided by 2 is 5. So you subtract 5 here, and then you square. And then you add A2. A2 was 900. But first we'll add first the BD cube you divide by 12. So our P here for the web part is 10 times 90 cube divided by 12. Then you add now the area to 900. Say the neutral axis 2 is this one. At this point we have our y2 at this point, so our y2 was 55. So we say 55, we subtract the neutral axis 28.68 square. So let's calculate first. So we'll start with this one. 100 times 10 cube divided by 12. So this is 8333.33 plus 28.68 minus 5. It's equals to 23.68. Then you square this way and then times 1000. So we'll have 560, 742.4. Then you add 10 times 90 cube, 10 times 90 cube divided by 12. So we have 607,500. Then you add 55 minus 28.68 square times 900. So we have 623, 468.16. So we'll have our second moment area answer. You add this one, 607, you add everything there. 560, 742.4. You add 8333.33. So our second moment area is 18,043.89. So this one is millimeters raised to 4. So we'll have to find the section modulus for this section. So section modulus said will be the I divided by the y max. So therefore section modulus will be I. Our I is 18,043.89 divided by y max. Our y max was 71.32. So section modulus will be divided by 71.32. So it will be 238.98 millimeters cube. So this is the section modulus. So let's find also the plastic moment capacity. So that the set B. So set B will say total area, which is 1900 divided by 2 is equals to 950 millimeters square. And then 950 divided by this 100 here, the French part, the 100. So it's the same as 9.5 millimeters. So 9.5 millimeters is this is the height of the flange part. 10 we subtract 9.5 millimeters, so we'll remain with 0.5 millimeters. So meaning we have the neutral axis through this point here. So this is from here to here is 0.5, then here is 9.5 millimeters. So this 9.5. So our set B, that's a plasma capacity will be, so we'll say 1000. The area of the upper part you multiply by bracket 45, you add 0.5%. So let's our set B, the plastic capacity will be the even. So it will be so we'll use this one 100, you multiply by 10. So our plastic capacity will be 10. This one, this 10 you multiply by 90, and then into 45 is the neutral axis of the web. Then you add 0.5, and then so 10 times 90. So this 10 multiply by 90, and then 45. Then you add this 0.5 from this point to this point here. So you say 45, you add 0.5, and then plus 100. This 100 here, you multiply by 0.5 times 0.5 over 2. So this is this 0.5 times 0.5 divided by 2, then plus 100 times 9.5 times 9.5 over 2 bracket. So our set P will be, so 45 plus 0.5 equal to, then you multiply by 90, and then you multiply by 10. So we have 49.50, then plus 100 times 0.5 times 0.5 over 2, 12.5, plus 100 times 9.5 times 9.5, 9.5 divided by 2. So we have 45.5. So we'll have answer you add plus 12.5 plus 49.50 equals 475 millimeter cube. So this is our plastic capacity. So for us to find the shape factor, but the question was find the shape factor of the T section, and then we'll also have to find the fully plastic moment if the yield load is 24 kilonewtons per millimeter square. So shape factor basically is set B you divide by the section modulus. So but our set P here is 475 millimeters cube. Then we divide by the section modulus, which we got here as 25 to 38.98 millimeters cube. So millimeters cube coils. So we'll remain with answer you divide by 25 to 38.98. So our shape factor is 1.80. So but you have to note that the shape factor must always be greater than 10 unit. It will be greater than 1, meaning this section is okay. So because it's more than 1, so we'll also find the fully plastic capacity, of which we'll have to pause it. So we'll have to find the fully plastic moment, of which it is. So we have Fy is equals to 24 kilonewtons per millimeter square. So fully plastic moment will be set P times Fy. So ZB is 45,475 times Fy, which is 24. So 45,475 times 24. 1091 400. So kilonewtons per millimeter square. So this is the fully plastic moment. So thank you for watching. So make sure you subscribe.